All right. Yes, I'm on screen. Excellent. Always weird starting when you can't see anybody else coming into a room and sitting down. I'm still not used to it. But yes, welcome. Welcome to this session. My name's Nash. I am a developer evangelist at a company called Twilio. And Twilio, if you don't already know, is a communications platform. It's a whole bunch of APIs that you can use in your applications to do things from making and receiving phone calls and sending and receiving text messages or WhatsApp messages, all the way through email and video chat. Basically, any way you want to communicate with your users in your applications, we have an API that can help you do that. So if you have any questions, either about this talk or indeed about Twilio in general, you can find me online. I'm Phil Nash all over the place. Or just drop me an email at philnash@twilio.com, and I'd love to hear what you're building and how we can help. As we go through this talk, I have both the chat in Slack open over to my right-hand side and the chat in WebEx. So if you have any questions, drop them in there, and if it's particularly important, I'll interrupt and answer at that point, or we can leave them to the end, depending on how that is. So yeah, I'm going to get going and talk about WebRTC and our lives on screen. You're on mute is probably a thing we've all screamed at a coworker or a friend or somebody on a video chat over the last couple of years, and I want to talk about how we can both overcome issues like that, but also how we in general can use WebRTC as a way to make better video chats for our businesses, for our applications. Because we have spent all this time on screen over the last couple of years, but you probably find that most of it is in an application. Right now, we're watching in WebEx. You might have spent a lot of time in Zoom or Teams or any other kind of application like this. And so, but I'm not I don't want WebRTC and the web platform to compete necessarily against these. You see, when we are chatting with people from work or with meetings or with friends or with family, and I'm surprised by how much over the last couple of years friends and family got really into Zoom calls and things like that, as it's definitely a work tool, but that's fine. Yeah, applications like that are great for these kind of things. Because you can agree beforehand, you can text your friends, you probably have an IT team at work telling you which of these video applications you're going to use in order to talk to your colleagues, and you can agree with your friends which one you're going to use and download that and be ready beforehand. Applications like this are not great for one-offs, for the kind of more business applications where you need to talk to or get in touch with somebody for a one-off reason. For example, like a doctor's appointment, telemedicine, that kind of thing. Or even, yeah, I think that's a good example. um, if you had to do a telemedicine appointment and you had to download a whole new application in order to use that, maybe even start up a new account, that's a bad thing. You don't need to be passing your data off to some third party just to talk to your doctor. Similarly, it's not great for specialist applications. And whilst telemedicine is mostly, just the video kind of chat, if you're doing something like remote learning or remote interviews, then something like Teams or Zoom or WebEx is not set up for that. It's set up for that generic workplace collaboration. Talking of interviews, I think it's HackerRank that managed to build a system where online they were able to both interview a face-to-face video, but also build in pair programming and chat into that system as well. And that's not the sort of thing you can do easily with the generic app. So WebRTC is for all those other applications. It's something we can build into our browsers, into things that can host those very custom applications and that only require the user to have a web browser installed. See, WebRTC, if you're not already aware, is real-time video, audio, and data experiences for your users on the web. The fact that you can join a WebRTC video chat with just a URL is a superpower of the web, right? It's shareable, it's linkable, and you already have the browser, you're already involved in that. And so that's why I think WebRTC is just it's a very exciting opportunity to build these experiences and build the experiences that you want. So for today, we are going to cover a few bits about WebRTC. First, the basics, just to see how all this kind of hangs together, how it works, and see what the underlying APIs are. Now, I don't expect anybody to come out with an ability to build a WebRTC chat off the back of the example code I'm going to show out of this, but it's important to know what is going on under the hood. It's also important to know that there are many tools and libraries out there that will do a lot of that for you. So understanding what's happening is good, but you don't necessarily need to know that to go on and build. Beyond that, we're then going to talk about controlling that user experience, because I want to be able to move our WebRTC application beyond just straight video one-to-one chat or one-to-many chat. I want to show the things that you can achieve with the other bits that kind of work around WebRTC to make these experiences possible. And finally, I've got a couple of tools and takeaways for you right at the end, so make sure you hang out till then. And as I said, please ask questions as we go through. I'm happy to answer things as we go. So, the basics of WebRTC. How does it all fit together? Well, this is what a WebRTC conversation might start off looking like. We have three participants. We have somebody on a mobile device. We have a desktop computer, apparently. Is that a floppy drive? CD drive? Who knows? And a laptop here. And I have this kind of central servery kind of thing that we'll get to use in a minute. And these three users, participants, want to talk to each other, want to stream audio and video to each other and see each other in real time. In order to do that, they first have to know that their other participants, their other friends, are available to talk to. And for that, that's the first thing we use our server for. We need to do some signaling. We need to basically announce presence for a start, and then also be able to pass back and forth data about how you can connect to the other participants that want to talk here. And so once we, normally a signaling server is a WebSocket connection. That way you can send and receive data without having to kind of reload a page or anything. And that is rather useful. So once you have some signaling set up and you've passed back and forth that connection data, there are two ways you can then connect in a WebRTC chat. One of which is peer-to-peer, and that's sort of the basics that WebRTC was built for in the first place. It's peer-to-peer communication, at which point each of the browsers on each of these devices is able to directly connect and stream audio, video, and data to the other peer and receive that stream back from them. This is really good. This is great. This is probably the most efficient way of doing things for small groups of people. Because as you see in this example, each of the participants is both sending a stream to another participant and receiving streams from those participants. So as the number of participants increases, your laptop has to send more streams and receive more streams. And that can get difficult. That can get difficult for the CPU and for bandwidth. There are two different ways that can get limiting on you. CPU, particularly, I think on the mobile device, is a difficult one. And so if that is a problem and you need to be able to have more peers join, you can do so also via a server. And this is not the same signaling server as earlier. This is what's called an SFU, or Selective Forwarding Unit. In this setup, the peer that each of the participants joins and connects to is this SFU. And so what this means is you only have to send out one stream of media to that server, and then receive streams back from it for all the other participants. This means that it's easier to scale, it's better to scale, but also that SFU in the middle can actually then control other things about the bandwidth and things like that. It can re-encode video, it can lower bandwidth requirements, it can change priorities of tracks, things like that. So this allows you to scale a bit further. but it does require the central server. So there are trade-offs in how you deal with WebRTC, but that's kind of how a connection looks. Now we have to cover a few acronyms in this as well, just to know what we're talking about. So ICE is the Interactive Connectivity Establishment Protocol. This is the thing that you will that those participants are sending around in that signaling section of the connection. And ICE is intended to ultimately provide IP addresses and port numbers on which a browser can be connected or contacted on. Now, this is because we have, your device on your network probably has its own private IP address on that network, and then the network itself will have a public IP address. And this is what we call NAT, Network Address Translation. However, in order for a browser outside of your network to connect to you, you need to be able to find that public address that can then be passed through to the private one and connect you up. So for that, we use a stun server, session traversal utilities for NAT. A stun server, basically, your browser makes a request to it, and it tells it back what that public IP address and port number is that it was making a request from, and that's where you can be contacted. That's really useful. Sadly, though, some particularly restrictive networks, normally big corporate networks, don't allow for that to happen. They don't allow for a public IP address connection for a machine on the private network. And so for that, we need a turn server, traversal using relays around NAT. I do like how people come up with these names in order to backronym things into it. But basically, the turn server acts a bit the same as the stun server in the first place, but when it works out that it can't connect back, you can make that connection to the turn server and then use the turn server's public IP address and port number as a connection there. So participants in the chat can connect to the turn server, and that will relay the media through to your private network. Thankfully, as this is the sort of thing that big corporate networks tend to be a problem with, it's actually not as popular, it's not as prevalent as being able to make a proper connection directly just using stun. But turn is there to media relay after if you need it. Cool. So let's have a look at the APIs. I like code instead of just talking about acronyms. Let's talk about the APIs themselves. There's kind of three objects / functions, methods that I think are important to know about. And I'm going to go through and describe them right now. So we start with get user media. Get user media is far and away my favorite web API that we've put into browsers. The first time I realized that we could use a function in a browser to get access to camera and microphone of a user, I was just kind of blown away. It was a thing you just couldn't do with the web before that, and I was very excited about it. And so the API has changed a little bit over time. Now it lives on this media devices object, on the navigator object, and it returns promises. It used to be a callback. But this is what it looks like right now. And you pass a set of options, a set of media constraints, and we'll talk further about media constraints later. In this case, these are kind of the default constraints. We want audio, we want video. This is going to pop a permissions dialog to the user. That's why it's an asynchronous call. And if the user accepts the permissions, then we'll get a media stream back and we can use it in our connection. I love how simple it is to get something quite so complicated as a stream of audio and video. It's just simply one function, and I love it. We get into more depths of what we can do with this later, though. Next up is the RTC peer connection object. We can initialize one of these, and we initialize it using ICE servers as an argument in the object. And this is why we need to kind of know underneath what those what that terminology is. So our ICE servers are our stun and our turn servers for our interactive connectivity. I always forget the E. I don't know how I forget this. Establishment. For the interactive connectivity establishment protocol, ICE servers. So this object of servers tends to include a stun server and a turn server, at least one of each. And you tend to include credentials for a turn server at this point as well. Since media relay is more of an expensive operation, you probably have your turn servers behind a credential, behind a username and password or something like that. Once you create your RTC peer connection object like this, you want to then listen for ICE candidates. And those candidates are the IP address and port number pairs that your browser may be contacted upon. And so as the peer connection object goes out and finds them using those ICE servers, it throws this event. And you can send those off to other candidates through the signaling mechanism. Now we had our stream, so we stream back from get user media, and we'll take our peer connection object. We need to add the stream to that so that it can work out what it can send to the other participants in this as well. So once we have our stream, we have our candidates. We can create an offer, and this offer basically is this list of things that our browser can use to connect to other browsers, including the codecs that are available, the streams that we're trying to send, those addresses we can be contacted on, and creating that offer just kind of says this is all of the things we can do. So once we've created that offer, we set that as our local description, but then using the signaling, send the offer to another peer that we're trying to connect to. So that peer will receive an offer via the signaling channel, however that works, and set it as the remote description of the peer that they're trying to connect to. Now, once they've set that as a remote description, they can create an answer, basically comparing the original offer with all the codecs and the addresses available for them with their own offer that they kind of internally create. That leads to kind of what's hopefully an agreement, a way that they can be connected, a shared codec that will be understood on both ends. And that becomes the answer. So we set the local description as the answer and send that back to the peer, which then sets it as a remote description. Once those two have agreed, that is the agreement protocol there. As soon as the offer and the answer are sort of agreed upon, then we can start listening. Then the peer connection object itself under the hood is going to do all of that connectivity and start sending the tracks back and forth between the peers. So what we have to do, all we have left to do, is add an event listener for a track. And when we receive that track, we can then show it in the UI, or make sound if it's an audio track, or do stuff with it if it's a data track. So that's the basis of how a peer connection is put together. There's a bit more dancing around in terms of creating and sending those things down signaling servers and things like that, but that's kind of how it all comes together. And I mentioned data tracks at the end there. That's using the RTC data channel. So we started with get user media, which makes our audio and video, but we can send arbitrary data down a data channel as part of one of these peer connection objects as well. And that allows us to send anything else we want as part of this connectivity. So to do so, you use the peer connection object to create a data channel, and you can name it stuff, and listen for message events coming down it. And you can do whatever you want with that message when it arrives, in this case, just logging it. Then kind of on the other side of the peer connection object, you just need to listen for a new data channel event. And once you have them, and this works a little bit like WebSockets as well, you need to listen to make sure that channel is open. And once it is, you can send data down it using just this event channel send method. Nice and easy. And so with all of that, with those things in hand, we can get to work on improving the user experience. Because like I said, it's good to know and understand kind of what's going on under the hood. And then, I mean, there is under the hood of the RTC peer connection object itself, which is doing a lot of work for us. But there's also, there are also libraries and frameworks that we can use to build this without having to know that. And that's useful. But when it comes to the user experience, that's where we can make a difference. That is the part of the call that we are now in control of. And that's what I think is really interesting. So first up, I want to go back to media. Get user media is really simple, but there's more to it. First up, it's important to know that I mentioned this pops a permissions dialog earlier, and if you accept the permissions, then the promise resolves and we end up with a stream object, and that's great. But if the user does deny the permission, then you do have to be ready to catch that and tell them about it. I'm sure, with the proliferation of other permissions popping out of browsers at various different moments, it's always possible for somebody to mistakenly block permission to a camera and a microphone. So always got to be ready to tell them what's happened there. Now, media constraints. I'm just going to zero in on this object here that we were passing to get user media. This is a very basic kind of set of media constraints that says I would like a microphone and I would like a camera and I would like the stream from both of them, please. And that's great. But there's more to it. There's more we can do with that. First up, if you're making a video chat of some sort, then you likely want the user who's trying to chat to be on camera. Now we'll get to how to pick a specific camera in a bit, but the easiest thing to do is set the facing mode to say user, because when you have, particularly if you have a mobile device with cameras on both sides, you probably want the front camera in order to have that user have their face on camera rather than everything else around them. So specifying in the media constraints that you want a facing mode of user will get you that front camera, at least on a mobile device. If you're on a laptop at that point, then most cameras face the user at that point. Facing mode has 4 potential options, which I think are really interesting. So environment tends to be the back camera on a mobile device, and still whatever your default camera is in a laptop or something. Right and left are supposed to be, I think, cameras to the right or left of a user, but I've honestly and genuinely never seen that work, so I don't know. I don't know what's going on with those. But facing mode user or facing mode environment allows you to specify basically front-facing cameras or back-facing cameras, and are really useful. Now, you can set a device ID for a camera or a microphone, indeed. I'm just using video as the example here. And if you set using this object saying exact and this device ID, then you can select a device specifically. If a person has more than one camera, more than one microphone, you can do this. I have a weird array of cameras, and we'll see that in a minute. But what you need to do, of course, is get that device ID. You can't just know it. And this is where the enumerate devices method comes into play. It also lives on the media devices object next to get user media. Whilst it doesn't require a permissions dialog to deal with this, it still is a promise-based API. And when you call off to enumerate devices, the promise will resolve with a list of available devices on the machine that the user is using. This is really useful. In this particular example, all I'm going to do is just loop through those devices and log out their ID and their label. Now, there's an interesting problem here, though. Some browsers do not tell you what the device labels are until you have actually requested and got permission to access the camera and audio, the camera and microphone in the first place. This is a protection against fingerprinting, so that the browser or malicious code can't kind of enumerate all the devices you have and use that to identify you around the web. So until you have given permission for access to the camera, this label will be empty. And indeed, I have an example of that. So I have just a demo app here for playing around with cameras. And if I look at this drop down in the middle, this is being built out of a call to enumerate devices. And I had to make up labels for the cameras I didn't have. So I apparently have 5 camera devices on here. 2 of them are virtual, 3 of them are real cameras, and we'll see that in a second. So if I go and request access to the camera, and there I am on screen again, now enumerate devices can go through and get all the labels, and you can see that this is my USB capture HDMI, and I've got other ones. I've got FaceTime, I've got C922, and then 2 virtual ones, which definitely won't work. So until you have got permission in the first place, you cannot know those labels, and so you need to plan accordingly for that. Let's stop sharing that for a sec. Otherwise, enumerate device is really useful. And once you have that device ID, you can use that to request like a different camera. So in this case, even though like camera 2 there was always going to be my FaceTime camera. Sweet. Next up is resolution. What's interesting is when you if you just send in the defaults, you don't tend to get a great resolution out of the camera that you're asking for, at least in my experience. The default is actually like 640 by 480, I think. And so you can set in the resolution of the video in this case by sending in a width or a height. Now, this is just a suggestion to the browser. It's saying, hey, I'd love to get 1920 by 1080. I'd love 1080p high definition video. Please, can I have that? But don't worry, just give me the best you've got. You can give those restrictions in a slightly different way. You can give a min and a max and an ideal, saying, you know, what I'd really like, but what I'm happy for it to fall within. And you can ask for those exact resolutions, but you run the risk here. And with any of these media constraints, you always run the risk of over constraining the browser. And if it's unable to provide the request that you've asked for, then it will throw an over constrained error. In this particular case, I think if I actually go back to this example, this is in Firefox. And so I'm going to start by taking out width and height. I'm not going to ask for a particular width and height. And so this has now taken my HD camera, but it's actually got it in 640 by 480, which, you know, not great. It doesn't look too bad, but it's not the best of resolutions. And it's certainly it's certainly less than my camera can achieve. And so if I ask Firefox in this case, I'd like 1080p resolution, please, from this camera, it doesn't give it to me. And I don't know why, but Firefox seems unable to give me 1080p from this camera. It can give me 720p. It'll give me 1280 by 720. And that's fine. It's cool. Sure. We have at least changed the actual resolution. We're now in 16:9 rather than 4:3, which we started in. And we can, like, you know, we can ask to go down as well. We can go 640 by 480 and then chop the sides off and go down to there. But I do find it odd. I don't know why Firefox can't do this. And if I asked Firefox for an exact 1920 by 1080, I'd get that over constrained error. I can go back, and this is Chrome, and let's see if I can get 1920 by 1080 out of this camera. We do. Right, so in Chrome, we can get this, and it's very happy about it, which is good. And we can go down really low as well, I think. Whoa, Chrome is actually very happy to give me anything I ask for. And so in this case, since I hit height of 0, it gave me a height of 1, which is not great. But there we go. You can actually see some pixelation, or I can see some pixelation on this 320 by 240 version. So Chrome is much better at giving those constraints than Firefox is. But the most important thing to be aware of is this over-constrained error. Just be careful that you don't over-constrain a browser. Next up, there are a bunch of more advanced media constraints, and I do recommend you kind of take a look through the list. There is actually there's a function where you can list out the supported media constraints in your browser. But one I just wanted to talk about because I thought it's both interesting that you can do it, and also maybe it's not that useful either, is the torch. So when you're setting media constraints from the advanced section, you pass in a list of objects. And in this case, we pass in torch as true, and we can turn on the torch on a supported device. And so I have an Android device here which supports that. Weird thing is you can't turn it off again. You can't pass a constraint in to say, hey, I no longer want this torch. It just doesn't turn it off. It's weird, but it's what it does. I'll talk about why I think that is later, but let's just see it working in action first. So I'm going to get the camera and see. Hopefully you can see. There we go. It's me on camera on this device, and I can toggle the torch. I've got a little button there, and the torch is on. But like I said, that button should toggle it off again, but it does not. The only way to stop it again is either to refresh the page, which is what I'm going to do now, off, or stop the video track entirely. And so I think this does have a use case. I think its use case is around scanning things, reading things via the camera, which I think is interesting. Like if you're scanning a barcode and you might be doing it in the dark, you can turn the torch on. But once you've finished scanning it, once it's done a complete and correct scan, at that point, you don't need the video track anymore, and you can turn it off, and that will turn the torch off again. So if you're building a barcode scanner, check out the torch media constraint. But also, there are other advanced ones available to you. Now, I've just kind of shown the media constraints so far, and we've seen media constraints in use when calling straight to get user media, but you can actually apply media constraints to a track that you already have access to. And so in this case, and in my example, if I'm using the same video track, then I can apply the constraints and change the resolution, or at least request a change in resolution, just by using apply constraints like this. One thing I'd like to warn about here is not to do that with the device ID constraint. This does work on some browsers, but it most importantly just doesn't work on Safari, particularly on iOS. Safari on iOS is not happy about you having access to more than one video track at any one time, more than one camera track, that is, sorry, at any one time. And if you try and do this, then you haven't finished the old track by the time you're asking for the new track, and Safari gives up on you. It's a bit unfair. So if you are trying to change the camera itself, don't try and apply constraints. Stop the camera, and then re-ask for permission to the new camera, and it will work in all browsers this way around. It is a shame. I'd love to be able to use both front and back camera for interesting kind of work on the iOS, but you just can't do it. They won't let you. What are we going to do about it? So I have shown a bit of a demo so far with this little resolution thing, but I do want to just change that up for, I've been working on a bit of a more involved video collaboration application in the browser. And I have a couple of kind of recommendations out of this section to do with media constraints. The first is, let's use a nice one. I use my microphone. Always provide a preview for your users like this, like allow them to check that their video is working, and allow them to choose and change things. So if they decided they don't want this particular camera, we can move to a different one over there. Yes. And I will talk about this audio thing as well. But we should be able to change microphone as well. Being able to do this before you join a room, before you join a video chat, allows users to get comfortable with what they are streaming and make sure it's working as well. So always provide a way to check and change those inputs, and mastering media constraints is the way to handle that. And so understand the available media constraints to you. Things like resolution are really useful for things like video, but there are a bunch of others that you can take advantage of as well. Just make sure they are also capable in that browser that you're using. Next up is screen share. Screen share has been a painful thing on the web for years because it used to require you to build an extension in order to access the screen. Terrible. Thankfully, the browsers got together and sorted that out, and we now have another function on the media devices object, get display media. And get display media works almost the same as get user media. It returns a promise, which ultimately resolves to a video stream of the display chosen. Get display media will trigger a permissions dialog. And most importantly, whilst it is possible in, if I just do this, in Firefox, it's probably a little bit small because it's part of the UI here, but there's a little checkbox there saying, remember this decision. Are you allowed to, you can have the site, the browser, remember that the site is allowed to access this camera. But when we're dealing with get display media and the screen, that permissions dialog will always pop up. There is no remember this. And this is so a malicious site can't kind of get access to the screen one time and then surreptitiously start recording the screen sometime later when you might be using that screen for something else that you're not aware of. So there's always permissions for this. And that's important. That's an important part of the web. So I can show you screen share at work. That's a virtual camera. That's not going to work at all. Okay, sure. We'll use the FaceTime camera. It's not very pretty. And so I'm just going to log into a video chat room here. And my video should come up. There it is. I'll come back to that later too. And I can share screen. And so in Firefox, we get this allow local host to see your screen. I'm just running this locally. And either windows or screens that I can look at. So I got screen 1. What's on there? That's a bunch of code I was working on. And screen 2, I think, is Slack and WebEx. Yeah, there we go. And screen 3 is the one we're looking at right now. So I like the way that Firefox deals with this. You've got this little preview window of it. And let's do it. Let's go into Infinity, share the screen that is sharing the screen that's sharing the screen. There we go. And we have access to this. I love this. It's just another nice, easy API that we can use on the web to do powerful things. Now, we see right in the middle, it's a little bit small, but we've got this you're sharing your entire screen overlay, which also has a little button. This comes up in in Chrome as well when you're using Chromium-based browsers, a similar one. It normally has a stop sharing button, which you need to handle. You need to handle the track stopped event if somebody clicks on that. And so again, if I click share screen again, it's going to ask me for permission again, which is great. And it's going to show me that, and there we go. And back on the screen. But you can also stop the track yourself just with a button there, and we're back in control. I'm going to disconnect from that for the second. So sharing screens, super easy. No longer need to use an extension. If you Google for how to screen share in a browser, I actually have a bunch of blog posts which might come up in that search result. And some of them say, here's how to build an extension. Do not pay attention to me. Use Get Display Media. It's the right way. Now, the Web Audio API. Not strictly part of WebRTC, but I think it's super important for this. Now, the Web Audio API allows us to create, manipulate, and analyze audio in the browser. Now, in these calls, I don't think I necessarily need to create or manipulate audio, but analyzing it is really important. And I think it's a vital part of displaying audio to the user. And this comes into that part where we're checking whether a user is ready and comfortable to join a chat. And so if I go back to the demo here, you've already seen this visualization here underneath the video that says, hey, the microphone is working. And it shows to the user the microphone is working. Other kind of ways you can test this is have somebody kind of talk into this and then record that and play it back to them. But I really like this as just an obvious visualization of audio as you're making it. There's a couple of things we can do this as well. If I pick a microphone that is not a microphone like this loopback one, there's nothing there at all. And that's actually something we could be detecting inside this application. Like you've got a microphone, it's either hardware muted or not producing any audio whatsoever. So you might want to check that. Because even if I have my actual microphone on and I don't say anything, if I go quiet for a second, we can still see that it's picking up some background noise. And so that is at least saying that there might be silence, but we're detecting something background. If you get nothing at all, then you can notify the user and say, hey, your microphone's not working. We're expecting to get some audio out of this. And I think that's important, right? It's going to save us having people shout, you're on mute at people. Because it's the worst problem we have in all video conversations. Because people can see each other, see themselves on the camera, but they can't, in many different apps and things that we do, can't see if they are making sound to other people. And so you're on mute is a problem we can solve. Firstly, by using that Web Audio API to check that there's some sound coming from the microphone and displaying things to somebody else. And secondly, when you're in a call, when you're in a call, yeah, I'm going to join the call and mute myself. We can also kind of detect the idea of, so muting here is actually just disabling sending that audio to the connection, but we still have access to the microphone. So what we can do is clone that audio stream and pop it into a Web Audio API analyzer, and then if I'm muted within the application, but I'm kind of crossing a threshold of audio anyway, we can show a message to say, hey, are you talking? You seem to be on mute. So having the application shout you're on mute at the person, I think that's a better way of doing it. And that way they can check, either unmute themselves, or indeed, like I say, if we have that issue with a hardware mute or something like that, we can say we're getting no audio from you. So are you on mute? And are you trying to say something? What's happening? So yeah, it's a simple little thing that we can do using the Web Audio API that just makes a conversation like this better. Next up, talking about the data channel. I showed kind of how you add a data channel here and how you can use it to listen for incoming messages or send out messages. The beauty of this is the data is completely arbitrary. And so I have a couple of demos just to show what you can do with this. And I'm going to leave this version of the app behind. I actually have a second version of the app, which is not quite so pretty in its lobby, as you can see here, but does have extra things. Does have extra things in it whilst it's on. Now I don't need sound at this point because I will deafen myself. In fact, I do like to mute that just in case. I'm going to use two different cameras so that you can see two different me's in this. Oops, don't want to use the same name or I'll get myself kicked out. And so here I am joining two rooms at the same time. And just muting just to make sure, though there's no audio coming from the supposed microphone I'm using. And so in this application, I have built a couple of additional things. One is reactions. And so this literally uses the data channel to send that emoji down as part of a tiny JSON object. And you can send that down and you can see that I'm happy on this side where I'm clicking it on the left-hand side, but on the right-hand side, it's also appearing for the other person. I also like the idea that in this one, we can have different levels of emotion that we can pass over. And so if you click it 5 times, it grows to 5 times the size, and then you can pretend to be a really happy emoji. Or facepalm, of course, also useful. That was useful. Like I said, it's just sending a little object across the data channel that kind of says this is a reaction and this is the available reaction that we're sending. Really useful. Second one I built into this is a whiteboard session. And so this firstly triggers to say, hey, join the whiteboard. And then as I draw on the whiteboard, sends those drawings across to be drawn on a canvas on the other side. I can't, obviously, my handwriting in this is terrible, but, and you know, if we pick the other side, we can actually draw something back and send it back. I'm gonna send a little smiley face because I'm pretty happy with all of this. Oop. Let's fill that in, and that gets sent over. I'm still on yellow, aren't I? Nope, there we go. Oh, smiley face. I'm possibly pushing my computer a little far here, and that's not the smiliest of faces, is it? Oh my goodness, it was Halloween last weekend, and that is a Halloween smiley face, if you ask me. Cool, I'm going to disconnect and stop this whiteboard session because I think that is causing my machine to be very unhappy with me. We'll go back to the slides instead. But right, that data channel is just there for you to share data across like that, and it's brilliant. And so finally, I want to close up with a couple of useful tools, which I think will be useful for you if you are building applications like this. And first, I want to talk to you about some open source diagnostic tooling. Now, Twilio does provide does have a product where we allow you to build WebRTC video applications. That's a paid for product. I'm not here to talk about that. But earlier this year, we open sourced a set of diagnostics tooling that you can use in any video applications to give you access to some interesting data and help you get users from joining the call to a successful call. And so I have a little demo of how that works right now. I'm going to close that down. And this was just a demo page I wrote using the tooling underneath. The tooling allows us to do 4 tests. Now, I've kind of talked about testing audio input and video input so far, but that's not all. Like, being able to test the connection speed is really useful to understand like what resolution you should be requesting the video at, and similarly like bit rate of the audio, so that you can be confident it's going to send it across the wire. And so the bitrate test here allows, actually does make a connection to a Twilio server in the background here, only in order to test the bitrate. And I was playing with this yesterday evening, and my bitrate was much worse, assumedly because everybody was on the internet, on the NBN last night, and making me around 4K rather than 12K as I got here from my 13 measurements. So the bitrate test gives us that confidence in the connection of a user. The audio input test is great because you can pick a microphone and it's going to give you a volume. It gives you events showing the volume, and then at the end we get this little report as well. And so you can visualize this volume. As I've kind of been doing in my other application, this is more of a simple volume thing rather than the fancy graph. And that tells me what the volume was. We can do audio output tests as well. Now, I don't know if you can hear this through WebEx, which is what I'm presenting through, but I'm getting an audio ding in my ear. Sounds like a phone's ringing. And we can visualize what that sound should have been. So it was definitely making the sound. And if I couldn't hear that, then there would be something wrong with my output, because there was a volume and we did a bunch of measurements for it. And finally, then there's the video input as well. So this allows us to go and get a video stream and see what it's doing. And this returns also some other reporting things on it. And I think this little application just reports like what resolution we got at the end. And there we go. It got 640 by 480. So this open source diagnostics tooling is a library that you can install into your applications. It's available online at GitHub under Twilio/RTC diagnostics, and is really useful for building that initial experience for users that is going to tell them whether they're going to have a good time inside a WebRTC call. So that's kind of our lives on screen. That's how we can build WebRTC applications to improve upon this, and how we can stop yelling "you're on mute" to people ultimately. The benefits I see here, just in WebRTC itself, is that it's everywhere. It's anywhere you have a device that has a browser on it, and I don't know of too many computers that aren't devices with browsers on, and so this means that WebRTC has that power, because in your applications, in your business, you can get somebody into a video call, the video experience that you want, by sending them a link anyway, for an email, or a text message, however you want. You can get somebody to your WebRTC experience, and they don't have to go and install and download some other application or sign up somewhere else. We have the tools to build great WebRTC experiences, and innovative WebRTC experiences. Not everything has to look like a Zoom call. And so hopefully I've given you some ideas about how you might go ahead and do that as part of this call. And I'd love to see what you will build with it. So that's all I have for you. Thank you so much for joining me, and I hope you have a great NDC. Again, my name's Phil Nash. I'm a developer evangelist at Twilio. And as always, please contact me anywhere online as Phil Nash, or drop me an email, philnash@twilio.com. Would love to hear from you. I don't think there's been any comments or questions in Slack or WebEx, but if you do have any questions, drop them in right now. Otherwise, go off and enjoy the rest of your conference. And thank you very much.